Hi, my name is Sidhartha Dash, or Sid Dash, and I'm the Chief Researcher at Chartis. Today, I'm going to talk to you a little bit about quantifying operations, leveraging new tools and techniques to quantify operational risk and look at operational risk in new light, if you will. So with that, let me dive in. Let's look at the background. Let's look at what has been happening in operational risk and the technological background that enables some of this quantification, if you will. Historically, operational risk has been one of the hardest to quantify. The challenges have included paucity of data, the nonlinearity and complex data structures, if you will. A large set of data is often available in text, documents, and other formats, workflow activities, process documents, etc. And that has made things very difficult to quantify operational risk, whether it be cyber risk, IT risk, operational resilience of organizations and systems, or supply chain risk, or any other form of operational risk, if you will. Newer operational elements such as environmental and ESG risks are just as equally hard to quantify. But what has changed? If you look at the background of what has really changed is the overarching digitalization of both financial institutions as well as non-financial institutions and non-financial corporations. What do we mean by digitalization in this context? What we really mean is the digital infrastructure that enables, let's take financial institutions or a bank for concreteness, and then we can expand the story as we go along. But if you look at the background, what's really happened is financial institutions are now essentially have a single or multiple digital backbones connected through workflow, data, messaging, and related infrastructure, which now means that whether an institution has many backbones or a single backbone, all activities essentially get managed through through the digital infrastructure. We can follow the data, we can control for assets, we know where each individual asset is located and what it is doing and what its current utilization is. We can look at the network and we can look at snapshots of the state of the network at all given points in time. And if this can be done internally, same can be said for external environment. Most institutions are connected to the internet. We can look at the health and the care of internet endpoints, and we can generate a very, very significant set of public information on what is happening in the overarching network, both internal networks and external networks. This now allows us to start thinking about data in different ways and start pursuing a variety of new forms of quantification and analysis. This generates also the issue of hard quantification versus soft quantification. Hard quantification means generating specific event risk type numbers, just as you generated market and credit risk. Softer quantification can mean things like giving you a perspective of the potential risk, or giving you more business intelligence oriented analysis of the general landscape of the risk probability distribution that exists in the system. But essentially, what it now means is there is a broad set of underlying data sets that we can actually capture. We can and this is really enabled, as I said before, by the overarching digitalization of the operating infrastructure of financial institutions, but also non-financial corporations as well. It is imperative, of course, as always, to use analytics and control mechanisms to be able to manage this environment. But the ability to build these analytics is what is, in our view, dramatically changing. Ability to change the nature of the controls, the ability to analyze the controls, the ability to think of the controls in a more quantitative way is what is structurally changing today. And equally, what we think is also happening is there is an integration between the different compliance capabilities into a broader range of technology infrastructures. So that in many ways, as I said before, this is laying the background. The overarching process-oriented GRC type activities is now increasingly integrated with DevOps and code development environments. That's why you have the whole, model risk is increasingly metasized into model ops, ML ops, etc. So what we are seeing is this whole integration of control functionality into a broad range of the broad technological infrastructure. We are seeing its integration into the development lifecycle. We are seeing its integration into middleware and data infrastructure. But this is, of course, now enabling reporting of a new type, as we mentioned, allowing a more rapid distillation of state of the system, more rapid distillation of state of the networks, more rapid distillation of state of usage and risk challenges and process challenges across the system, if you will. Now, in addition to all of this, if you look at some of the technology and operational environments that have really come through, the other elements include statistical options and which of course includes statistical AI. Statistical AI has allowed, mainly machine learning and neural networks, have allowed us to handle highly nonlinear data sets. NLP and now evolving Gen AI now allows us to handle textual data sets, convert textual data sets into quantitative forms, essentially allow us to handle textual elements almost the same way as we would handle quantitative data. It has opened up our view of what we can do with textual and control data sets, if you will. Now, all of this would be not possible without some of the other underlying data infrastructure. For instance, the other big element has been the growth of different types of databases, the NoSQL databases, vector databases, and vector and array-oriented databases, etc. There can be an explosion in data infrastructure, database management systems, many of which actually did exist before the NoSQL movement. For example, as we'll see in the healthcare environment, you already had a whole range of array databases. However, these tended to exist in specific niches. Today, the growth of NoSQL, scientific databases, array databases, have essentially opened the options. They have allowed us to start to store appropriate data in the appropriate context. If we have complex data, complex array-oriented data, we can store it in array and vector databases. We don't need to, we're not compelled to map it back into relational structures. Where we need to have relational structures, we can continue to have relational structures. And hence, we increasingly have these heterogeneous data infrastructure that allows us to store a broad set of data and allows us to manage data throughout its entire life cycle. This management of data throughout its entire life cycle gives us a new window to thinking about how to hold, control, and appropriately store and manage data. So as we will see, data infrastructure choices are incredibly important for institutions and vendors. As vendors start to think about how do they how do they do these type of process integration? How do they handle uh, uh, how do they handle the output of this whole digitalization environment that we've seen before? How do they apply the appropriate analytics, whether they are AI or otherwise? It is really important to think of where is the data held? How is it held? Is it held in the appropriate format? Can it be easily traded into the analytics, or perhaps we have to make a series of transformations to make it available to the machine learning model or the Gen AI model or any other NLP infrastructure that is being used. So databases, the range and variety of databases today available, the key challenge, as I said before, is to make the choices, the right type of array framework, ensure that the array framework is mapped to the data sets that are available to you and is not mapped to, liquid market time series array structure, for instance. So choices and choices. There is almost a gigantic buffet of options available in this data environment. But we shouldn't, as we emphasize the data storage and database and data management environment, we we shouldn't lose track of the semantic framework of this data and the need to have uh, appropriate data models. Uh, Again, as we handle these varied data sets and as we handle these varied data sets across the enterprise, we need appropriate data models to be able to handle this. And this, in our view, is in many ways going to be the differentiator between successful programs in operations quantification versus unsuccessful programs. Do you have a model that looks at all the assets, the data sets that go into the analytics infrastructure, the organizational hierarchies, multiple ways to represent organizational hierarchies, perhaps the process model as well. So ability to bring all of this together and have different representations of the data model, and perhaps represent the data as an ontology, perhaps represent the data as a domain specific language. All of this has very, very important consequences, as we will see. For instance, if having these data intermediates, for instance, makes it much easier to apply some of the more sophisticated machine learning or NLP techniques, including Gen AI techniques, as we go along, if you will. That sort of brings us to the final enabling elements of the data architecture, i.e., the process mining and workflow analysis. As the digitization environment spreads, we find that process mining and data infrastructures have become more sophisticated. We can actually analyze, as I mentioned before, processes of their semi-quantitative activities, which allows us to think about controls, processes, and workflow elements in a completely different way. So what we are really seeing is that processes have converged with new technologies, allowing us to allowing the sort of us to leverage our new types of databases, orchestration engines, domain specific languages, and essentially think about processes in a completely different way. And finally, we would argue that operational quantification requires a lot of large-scale data and data management. And interestingly enough, we are also seeing the commercialization of operational data, which is probably one of the fastest growing areas in the data sector. We are seeing a broad range of new data providers who are providing operational data. This is true for both financial services as well as non-financial services, but in particular, in certain industries such as energy, etc., we've seen the most rapid growth of operational data, commercialized operational data, and being able to take this commercialized operational data, the benchmarks that have been developed and are being developed in this, is going to be the critical differentiator in being able to quantify, analyze, score, and attribute in operational risk elements, if you will, going forward. The universe of commercial data is rapidly growing. It includes, as I mentioned before, things like supply chain data, consensus and consortia benchmarks, core entity data, perhaps enriched with ESG and other spatial and operational elements. And finally, the need to bring all of that together implies, again, the ability to handle very large data elements, the ability to handle many varied data elements. In some ways, fortunately, the technology is available today. So with that, I sort of conclude our core themes, if you will. The operational risk quantification has been enabled through internal data availability, which has really been enabled through digitalization, a broader system, whether it's the broader global network that we call the internet, or just interconnections with other organizations, or general operational data available today is much larger and has grown 100-fold, and now enables the analysis, more granular analysis, more specific risk framework and modeling, and developments in workflow and process technology have allowed us to think about workflow and process elements in more semi-quantitative ways, allow us to analyze, mine, and store them in different ways. And essentially, this has opened up the quantification of process analysis, if you will. A lot of what we are talking about today, we are thinking through the lens of the financial industry, but it has grown across the board. One of the most dramatic elements in digital interaction is something you can see in the energy industry, but we are seeing the growth of these trends in energy, healthcare, manufacturing, and a broad range of other industries besides the financial markets, if you will. Financial markets and consumer finance elements, if you will. With that, I close.